Hello everyone, this is Dmitry from Galileosky, and today we will keep exploring filters in configurator. The math filter is similar to the mathematics block in easy logic. It has all the same math operations. This filter can be used in cases when you need, for example, to work with two or more fuel level sensors. You can receive the cumulative fuel level for a vehicle by summing up values from all the sensors. For example, locomotives have 4 fuel tanks. Let's see how to get the joint fuel level from all of them at once with filters. To set this filter, we need 4 getParameter blocks, 4 tar filter blocks with tarring tables, and 3 math filter blocks. Every math block works with the left and right operands. So, first, we need to sum up values from 2 pairs of tar filters, and then sum up the results. In math filter settings, we can choose the math operation. In this case, choose addition in all 3 blocks. Now we need to choose one of the empty protocol tags to send the filter results to the monitoring software. Do not forget to add the chosen tag to the main packet on the protocol tab. Integration filter is for converting instant values to physical units. For example, if you found the instant fuel rate or the current speed in the CAN bus of your vehicle, the integration filter can help you to turn the instant fuel rate to the total fuel consumption and the speed to the mileage. As we remember from the basic math course, the speed is the first derivative of distance by time. By integration, we can find the distance covered at the instant speed by the time between events that null the filter value. The same way, we can find the consumed fuel, applying the integration to the instant fuel rate value. The second parameter to this filter is an event that will reset this value to 0. It makes sense to use the point recording as such an event. In this case, you will have to sum up the values on the server side to get the total fuel consumption or the total mileage. This will also help you to avoid losing the value in the tag because of the overflow. Let's try to use this filter in the practical case. For example, I want to get mileage using the current speed value from the CAN bus. For example, I have the current speed value from the CAN bus in the tag CAN 16-bit R0. I'm choosing this tag as the data source. Integration is the filter to use. The result of integrating the speed is the mileage, and I'm saving the result to the CAN 32-bit R0. A 4-byte tag like this can save value up to 2,147,000,000. This should be more than enough for the total mileage, even if you don't null the tag. Still, if you would like to get the sum on the software side, add the point saved as the null event. If you don't need to reset the value, you can use one of the empty CAN tags as this event. I'm choosing the second option. Let's check the results in the monitoring software. As you can see, in the first CAN tag I have the current speed, and the second CAN tag has the integrated mileage, which is increasing over time. The last filter is counter. This filter gives us simple sum of values in the chosen tag. Unlike with the integration, you just get a running total of values in the source tag as they come in. As with the previous filters, we need to set one of the tags as the data source and the null event. You can select point recording as such event. Now let's figure out how to build a complex filter and in which order filters should be applied. I have already told you about processing the data from multiple fuel level sensors on the same vehicle. You now see a couple of fuel level filters on the screen, and the mass filter that sums up fuel level values from 2 sensors. In theory, it should work, but unfortunately it won't. Please note that we use the same tags that hold the original values as the tags where the filter puts the result. I have already pointed out that this is not the best solution because sometimes we can get raw data instead of filtered values on the software side. The thing is that the math filter also uses the fuel level sensor tags as the input data sources. This math filter will also use the raw values but not the filtered results as the input data. Okay, let's remake the filter so it works properly. It's actually quite simple. We just need to use the output data of the fuel filters as the input data for the math. I am now connecting outputs of the fuel filters to inputs of the mass filter. Now the process data from the fuel level sensors will be summed up. As you can see, filters are quite handy and they are much easier to use than easy logic. I hope this video series was helpful for you and now you'll start using filters in your projects. That's all for now. It was Dmitry from Galileosky. See you later.